Hi, welcome to this lesson on Euclidean geometry, similarity and congruency. Let's have a look at congruency in triangles. So we'll start off with the definition, and we say that two triangles, ABC and PQR, are congruent to each other, denoted by that symbol there, if and only if all the following conditions are satisfied. So unlike similarity where you just need to show one of the two, when it comes to congruency in triangles, we need to show both of these cases are true. So we need to show all corresponding angles are equal. So in the order it's written, those angles must be equal to each other. And then condition 2 stipulates that all corresponding sides are equal in length. So not in proportion like similarity, but they must actually be equal in length. Okay, so mathematically this tells us that two triangles in the plane are congruent if and only if they are equiangular for all corresponding vertices, and each corresponding side of each triangle is equal. Okay, so when we did congruency of polygons, it is very generalized. But when it comes to congruency of a specific type of polygon, in this case a triangle, we've developed 4 special rules that we can use to determine whether two triangles are congruent or not. So the first test for congruency of two triangles is known as the SSS, or side-side-side test. So we say that if all 3 sides of triangle ABC are equal to the other 3 sides of triangle PQR, so that is, if you have AB equals PQ, if you have BC equal to QR, and AC equals to PR, then triangle ABC is similar to triangle PQR. And look at the order that we wrote it in. AB is equal to PQ, right? BC is equal to QR, and AC is equal to PR. So that order in which you write it is really important. Okay, so this will also imply then that angle A equals angle P, angle B will equal angle Q, and angle C will equal angle R. The next test for congruency of triangles is known as the SAS, or side angle side. So if we know that 2 sides and an included angle are equal in each triangle, so that means, for example, if you have AB equals PQ and AC equals PR, and the angle between those 2 sides are equal, so angle A equals angle P, then triangle ABC will be congruent to triangle PQR. Okay, and you can sort of visualize and see why this is true, because if you take AB and AC, let's say those are your 2 arms. Okay, so if you take your 2 hands and meet your fingers and call that point A, the vertice, depending on that angle you make, the closer your hands are or the further your hands are apart when the tips of your fingers are touching, that'll determine that third side opposite the angle A or P. Right? And if they are the same angle, then logically the same distance between your palms, for example, will be preserved. So therefore that'll tell us that this distance is equal to that distance. And therefore we'll have all 3 sides equal to each other. Therefore this side that is 3 bars long should have an angle X here, and that same opposite angle must correspond there, and then that'll have an angle, let's say dot here, for example. So all angles and all sides, corresponding sides, are equal. So this side angle side is another test for congruency. And again, to use this, we must have 2 corresponding sides equal in length with an angle included between those 2 sides that are equal to each other. That's the only time it'll work. Then the next test for congruency is angle side, AAS. So this one works that if you have one corresponding side and 2 corresponding angles that are equal to each other. So for example, in these 2 triangles, if angle A is equal to angle P and angle B is equal to angle C, and the angle B and Q, angle B is equal to angle Q, if those 2 angles are equal and the side that is on that's adjacent to that angle are also equal in length, okay, then that tells us that triangle ABC will be congruent to triangle PQR. And again, look at the order. We know that angle A equals angle P, and we know that angle B equals angle Q. So by angles of the triangle, these 2 angles must be the same, because when you sum them up, it must be 180 degrees. Okay, and you can see this side is in between these 2 angles, right? So opposite it is also the same angle. So everything matches up nicely here. So this is another test for congruency. So again, the only way this one works is if you know two corresponding angles are equal, and on one of the sides of the corresponding angles, if they have the same side lengths, in this case BC and QR, then you can conclude that those two triangles are indeed congruent to each other. Okay, and the last test that we have for congruency in triangles is the RHS test, which stands for right angle, hypotenuse, and side. So this one is best used if you have 90-degree triangles, okay? So this one says if the hypotenuse and one corresponding side of a triangle is equal to the hypotenuse and one corresponding side of another triangle, then they are congruent. So this means that, for example, if you have AB is equal to PQ, and you have these hypotenuse, BC and Q are equal to each other, so they're opposite a 90-degree angle. That's why we say right angle, hypotenuse, and common side. Then these two triangles are congruent. And again, look at the order that we write it. ABC is congruent to PQR because AB is equal to PQ, that's the common side. The angle A is equal to the angle P, that's the 90 degrees. And the common side, or the hypotenuse rather, is the BC and the QR part. Okay, and that's the fourth test for congruency in triangles, and this one is only used when you have right angle triangles. So let's have a look at an example of congruency in triangles. So LMNO is a quadrilateral such that LM is equal to LO, so we have adjacent sides equal, and the diagonals intersect at S. Okay, that point S with MS equals to SO. So this basically looks like it could be a kite. The only thing we're missing is the fact that we must show that this is a 90-degree, and we need to show that these two sides are equal. So if we do that, we can actually use properties of a kite, right? But we don't know that yet. Okay, we don't know if that's true or not. So we can't just go ahead and use properties of kite because we're not told that this is a kite, although it satisfies some of the conditions to be a kite. Okay, we need to prove that angle MLS, so this angle here, is equal to angle SLO, which is this angle here. So that's the objective. So whenever you want to show angles are equal in a triangle, right, it's best to see if we can try get similarity coming out, because then we know that corresponding angles are equal, or even congruency for that matter. Okay, so if you look at triangle MLO, this is isosceles triangle because the length LM is equal to the length LO that was given to us. So that means that angle LMO, so this angle here, is equal to angle LOM, which is this angle here. All right. So now what do we have? If you look at triangle LMS, this one here, you have this side LMS, and that's equal, and that's the same angle. And then in this other triangle here, which is LSO, we have SO is equal to MS, we have LO is equal to LM, and we have this angle LOS is equal to angle LMS. So what we have are two common sides that are equal and an angle included between them that is equal. So by side angle side, we can conclude that those two triangles in that order are congruent to each other. So by congruency, that means that angle MLS, right, in that order, angle MLS, so this angle here, must equal this angle SLO, which is this angle here. So therefore, we've shown that that is the case. All right, by using congruency. So keeping on with that, we will now want to prove that triangle LON is congruent to triangle LMN. Okay, so if you look at these, right, we have sides and angles. So it's probably going to be one of the congruency tests, angle, angle, side, or side, angle, side. So that's, you just have to keep in your mind of the 4 congruency tests. What information do I have that I could use for that test? Okay, so that's what you got to ask yourself. So we know that LM is equal to LO. All right, and that's good because we asked to prove that, already showing that those two side lengths are equal are good for us because we want congruency. So we want corresponding sides equal. And angle MLS, we've shown that that's equal to angle SLO by the congruency of these two smaller triangles on the top here. Okay, so we can say that those two angles are equal. We've proven that. We also know that LN, this long line here, is a common length to both triangles that we are looking at. Because remember, triangle LON is this triangle here. Okay, and then triangle LMN is this one here. Okay, so this was given to us, LM and LO essentially, right? LM and, okay, so that should be LM and LO is given to us. And angle MLS, we proved that that angle there is equal to angle SLO, which is this angle here. We've proven that in the previous one. And then LN is equal to itself. So what do we have? Two sides that are equal with an angle in between them that is also equal. So by side angle side, we've shown that angle L to O to N, so from the dot to the two side to the other side. So we follow that pattern from the dot to the two side bar, so to M, to the last part N. Okay, those two triangles are congruent by side angle side, and that's exactly what we wanted to prove. And then lastly, we must prove that MO is perpendicular to LN. Okay, so if we do that, then we're very close to showing that this is indeed a kite. Because we prove that the two triangles LMN and LON were congruent, that means that the corresponding side lengths were equal. So if we show now that these sides MO and LN are perpendicular, we've actually successfully proven that this shape is a kite. Okay, so that's pretty cool. Okay, so we've proven that triangle LMS and triangle LOS are congruent. That was the first thing we did. So angle LSM must equal angle LSO, okay, by congruency. So that means, so if I draw my pen here, this angle and this angle must be equal to each other by congruency. But we note that if you add these two triangles, they must give you 180 degrees because MO is a straight line. Okay, so because LSM is equal to LSO, and we've got this equation, I'm going to substitute LSO with LSM. So I have two amounts of it equals 180. So therefore I've shown that LSM, which is the same as LSO, is both 90 degrees if I divide both sides by 2. Okay, so that shows us that this angle is perpendicular or 90 degrees. Therefore, we can conclude that the line MO is perpendicular to the line LN. And what we've actually shown in the bigger hierarchy of the story here is that these congruencies have allowed us to show that this quadrilateral is indeed a kite. All right, so that's pretty cool. And I'll see you in the next one.